In this video, me and my friends will share about the application of polynomial function in daily life. As we know, polynomial function is applied in many areas such as engineering, electronics, healthcare, and so on. One of the most obvious example is the engineering in construction of roller coaster to determine the shape of the rail. Here, as an example, we will discuss about the weight function of a patient that suffers from illness for 7 weeks. The weight is modeled by function w of n equals to 0.1 n cubed minus 0.6 n squared plus 110, where n is the number of weeks.
To determine the interval where the weight function is decreasing or increasing, we use the first derivative where w plus n is equal to 0 to determine the stationary point of the function. Then the value of n have two numbers which are 0 and 4. Choose any value less than 0 and substitute into w plus n function, and the answer will become positive value. This shows w is increasing from negative infinity until 0. Next, substitute number 1 or 2 or 3 into w plus n function, and the answer will become negative, and this shows w is decreasing from 0 until 4. Lastly, substitute any value greater than 4, and the answer will become positive, and this shows w is increasing from 4 until positive infinity.
The maximum value of a function is the highest turning point of our text, while the minimum value of a function is the lower turning point of our text. To find the maximum or minimum point, we use the first derivative test, which is w prime m equals to 0. We found that n is equal to 0 and 4. When n equals to 0, wn equals to 110, and when n equals to 4, wn equals to 106.8. Since the graph is increasing from negative infinity to 0 and decreasing from 0 to 4, we can conclude that 0 and 110 is a maximum point. The graph is decreasing from 0 to 4 and increasing from 4 to positive infinity, so that 4 and 106.8 is a minimum point.
Inflection point is a point of a curve change in the direction. The first derivative test can sometimes distinguish inflection point from extrema for differentiable function. In this case, we use the second derivative test to find out the inflection point when w double prime n equals to 0. The equation of w double prime n equals to 0.6 n minus 1.2. We let 0.6 n minus 1.2 equals to 0. We can find out the value of n at inflection point equals to 2. Then we can find patient's weight by substitute n equals to 2 into the normal equation, where wn equals to 0.1 n cubed minus 0.6 n squared plus 110, and we get the result that is 108.4. So the inflection point for this function is 2 and 108.4.
Now I'm going to talk about the concavity of the function. In order to find the concavity of the function, we need to find the second derivative of the function. The second derivative of the function is 0.6m minus 1.2. Before that, we know that the value of m for the inflection point is 2. For the interval between 2 to positive infinity, the function shows a positive value. The interval between 2 to positive infinity for the function concave upwards. For the interval negative infinity to 2, the function shows a negative value. The interval between negative infinity to 2 for the function concave downwards.
Okay, so now we are finding x-intercept and y-intercept. For y-intercept, before the illness haven't begun, which means n equals to 0, the patient's initial weight is 110 pounds. In this case, there is no x-intercept as the weight of a human will never be 0. From all the information calculated, we can get the graph of the weight function. In a nutshell, polynomial function is fun to learn and can be used in many fields. Thanks for watching.